In our example, before we implemented façade, we realized that these APIs had a complex interface, and the client was directly dependent on these APIs. So, if we want to port the application to a different platform, then it would have been difficult to do so because there's a tight coupling between the client code and these functions. Then we implemented the façade design pattern. We created console class as the façade. The client will interact with this console class that will internally use the functionality of these operating system APIs. So this way, the dependency of the client on these APIs is reduced. The advantage is now these APIs can internally change, but the client will not be affected. One other advantage that we get in C++ is the compilation dependency of the client on these functions is removed. This means we don't have to compile the client if these functions change. Instead, we will only have to recompile the implementation file of the console class. Now let's see what are the pros and cons of using the façade. Façade isolates the clients from components or classes that have a complex interface. This in turn reduces the number of objects that the clients have to interact with, and this leads to weak coupling. Therefore, the underlying components can change without having any impact on the client. And as I said earlier, the façade pattern also reduces the compilation dependencies on various components in large systems. One important feature of façade is that it does not hide the underlying classes of a subsystem. Because of this, clients can still use those classes if they want to. If we want to use the low-level functions of the operating system or some library, we can use the façade that can provide an object-oriented interface to those functions. We can also use the façade to create object-oriented interface to low-level data structures. For example, if we want to use a dynamic array or a list, rather than use the functions directly, we can create a class, and that class will act as a wrapper to these data structures. But there are some disadvantages of the façade pattern. If you overuse it, then it can lead to too many layers, and because of that, the performance of the system may degrade. When to use the façade pattern? You can use this pattern to create a simple interface to a complex system. This interface can be a default view for most clients, and for other clients that need more control or customization, they can use the underlying classes directly. In some cases, you may be working on a system for a long time and it might have evolved and has become more complex. You might want to create a façade to provide a simplified interface to such system. But for early users, they might want to retain their old view of the system. So they might want to use the classes directly. You can also use this pattern if you are dependent on low-level functions. You want to avoid the dependency on the low-level functions of a specific OS, or you may want to provide an object-oriented wrapper. You can also use this pattern if you are working in a project where there are team members with different level of experience. So you might want to provide simple interface for novices, and the power users can use the classes of the system directly. If you find there are too many dependencies between the clients and the implementation classes of a system, then you can also use the façade pattern in that case. That's all about façade design pattern. I'll see you in the next video. Goodbye.